Hi guys, this is a video by Darklink Does Math. The content in this video is geared towards 6th grade math standards. These videos are public so that my students may access this information easily, as well as anyone else looking for math help. I hope you find this video helpful. If you do not, I hope you can find what you are looking for elsewhere. There's a lot of information out there. Be aware that I am not perfect, so there may be the occasional mistake. I apologize in advance if this should happen. So today, we are going to be going over lesson 3.1, which covers dividing fractions. We have 3 vocabulary terms to go over. The first being improper fraction. Improper fraction is a fraction in which the numerator is greater than or equal to the denominator. A fraction in which the numerator is greater than or equal to the denominator. So in other words, your top number can't be bigger or the same as your bottom number. So here are a few examples of improper fractions. 4 over 4. Because the top number or numerator is equal to your bottom number or denominator. 5 over 4, top number is bigger. 7/5, your top number is bigger. And 15/2, again, your numerator is bigger. So improper, as it implies, it's not right. It's not correct. So we can never leave our answers improper. We must change them. To what? Mixed numbers. So mixed numbers are our next term. What is a mixed number? A mixed number is a number with a whole number part and a fraction part. So basically, a whole piece and a part of something. Like if you have 1.5 cookies, you have one whole cookie and then you have a piece of a cookie. So you're going to have a mixed number. So a few examples of what mixed numbers might look like would be 4 1/2. So you have a whole part and a piece. And then we have 3 15/16. So 3 wholes and then a piece. And then one more example, 1 1/12. So one whole part and then a piece. Our last term, reciprocal. Reciprocal means you have 2 numbers whose product is 1. Product means multiply. So we're basically saying if you have 2 numbers and their product, or when you multiply them, you get 1, they are probably reciprocals of each other. So an example of a couple reciprocals, 4 1/4 are reciprocals. Why? Because if I take 4 and multiply by 1/4, which is supposedly its reciprocal, I'm going to get, well, first I'd put my whole number over 1, multiply across the top. 4 times 1 is 4. 1 times 4 is 4. That's improper, so I would have to take top divided by bottom, so 4 divided by 4, and I would get 1. So I take the product of these 2 numbers, and I get 1. That means 4 1/4 are reciprocals of each other. Now, if you look at these 2 numbers, essentially, they're just flipped upside down. So if I take 4 and flip it, I get 1/4. If I take 1/4 and flip it, I get 4 over 1. So really, to find a reciprocal, you just need to flip your number. And we're going to be doing a lot of that whenever dividing fractions. All right, our first type of example is dividing whole numbers by proper fractions. So our first example says, some children shared 4 granola bars. Each child had 2/3 of a bar, and I want to know how many children there are. Why we can't just count the number of children, I don't know. So we're going to have to do it the complicated way. Okay, we're going to do it 2 different ways. I'm going to show you 2 different methods on dividing fractions. Typically, you use the method that is most appropriate for you. Unless your assignment specifically states use a particular method, it's usually up to you on which method you decide. So make sure you're following your instructions for whatever class you're in. Okay, so we're going to first show bar modeling. No, it's not some new crazy math or anything. This has been around when your grandparents were here probably. My grandparents for sure. Okay, so for bar modeling, first let's look at our problem. We have 4 granola bars. Each child is going to get 2/3 of a bar. So I want to know how many 2/3 will fit inside of 4. Or in other words, if I have 4 granola bars, how many times can I cut it up into 2/3 pieces? So our problem is going to be 4 divided by 2/3. For bar modeling, the first number tells you how many bars to draw, assuming it's a whole number. So we have a whole number, so we want to draw 4 bars. And this is the first thing you're going to do. So we draw 4 bars. These bars represent our granola bars that we're going to divide among the kids, which apparently we don't know how many are in the room. It's a little weird. Okay. Next, we look at the second number, 2/3. We first look at the bottom number. The bottom number tells us to cut. So we're going to cut or slice these bars into thirds, or 3 pieces each. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Again, that was our second step. Our third step, we have one more number to look at. The numerator, the top number. That tells us what to count by. And again, this is our third step. So we're going to count by groups of 2. I want to know how many groups of 2 I can get out of these. You can shade, you can color, you can circle, you can use brackets, however you want. We're going to circle. So here's one group of 2. There's a second group of 2. Let's see. There's a third group right there. There's a fourth group, a fifth group, and then it comes out nice and even. 6 whole groups. So how many children were there? We're going to restate the question in a complete sentence. We're going to say there were 6 children. Okay, a second method. This is the more recognizable method. And it is multiply by the reciprocal. So when dividing fractions, we actually don't ever really divide fractions. It can be a little complicated. Instead, we multiply by their reciprocal. So what does that look like? Well, first you write your problem. In this case, 4 divided by 2/3. We're going to take our first number, 4, and we're going to keep it. So keep your first number. And sometimes it might be helpful if you write these little letters to kind of keep track. There are 3 steps. The first one being keep. Keep the first number you have the same. Second, we're not going to divide fractions ever. We're going to multiply. Why? Multiplication's easier, so why not? So we're going to change the sign from divide to times. So our second step is change. So keep the first number, change the divide sign to times, and then we're going to take that reciprocal of the second number, in this case, flip it. So 2/3, the reciprocal of that is 3/2. So in other words, we flipped the second number. So we kept the first number, changed the divide to times, and flipped the second number into its reciprocal. And now we're going to multiply. So 4 divided by 2/3 is the same thing as taking 4 times 3 over 2. And this will be a lot easier for us. Now, before you multiply, make sure you have both fractions. So if you have a whole number, put it over 1. That way you can multiply across the top and multiply across the bottom. Okay, there are shortcuts, and I will show you some shortcuts starting on example 4. In the meantime, we're going to do it the long way. Across the top, 4 times 3 is 12. 1 times 2 is 2. I look at my fraction and determine if it's proper or improper. This is improper. You have a larger numerator on top. You can't. So what do? We do long division, whether it's in your head or showing your work if they're more complicated numbers. 12 divided by 2 can be done in your head. So 12 divided by 2 is 6. So our answer is 6, which as it should be because we've already done this problem. There were 6 children. I hope the answer doesn't change. That would be weird. So again, this is the more traditional way. We keep the first number, change the divide to times, and flip the second number into its reciprocal. And then we multiply, and we don't ever really divide. Okay, our second example. A bottle contains 2 quarts of cooking oil. A chef uses 8/9 quarts of cooking oil each day. We want to know how many days will the cooking oil last. Why would he want to know that? Well, if he's going through oil really fast and he discovers he's going to go through it in 1 day or 2 days, he might need to go buy some more. We're going to do it 2 ways. Again, method 1, bar modeling. Just a nice visual of seeing what's happening. So let's look at our problem. We have 2 quarts of oil, and basically we want to divide it up into 8/9 quarts sections, basically, and see how long it's going to last. So our problem is 2 divided by 8/9. How many of these can we fit out of those 2 quarts? All right, we have a whole number. So again, that means that's how many bars you're going to draw. You're going to draw 2 bars. These 2 bars represent our 2 quarts of cooking oil. Next, we look at 8/9. First, we have to look at the 9. So again, drawing the bars is your first step. The second step, you look at the denominator, 9. That is how many times you're going to cut those bars into, and that's your second step. So let's cut it into 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Last number to deal with, 8. That's what you're going to count by. And that's your third and last step for this one. So we're going to count how many groups of 8 there are. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to shade those in. So there's one group of 8. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. There's another group of 8. So I have 2 whole groups of 8. So 2 whole groups. Now, you'll notice I have some extras. I have 2 extras. So I have 2 pieces left over out of, what was I counting by? I was counting by 8. So I have 2 pieces left over out of 8. So we're going to use those 3 numbers, 2 wholes and 2 pieces out of 8 to write our answer. So our answer, how many 8/9 will fit inside of 2? 2 and 2/8. Now this is not our answer, and not just because it's not in a sentence. Always look at your fraction. First, you want to make sure it's proper. Is the smaller number on top? Yes, absolutely. That's good. Next, do you have any common factors? So does 2 and 8 share any common factors? Are there any numbers that will divide into both? Yes. That's bad. That means it's not simplified. We must always simplify our fractions. Otherwise, you don't get any credit. Answers must always be in simplest form. So what am I going to do? I'm going to look for the greatest common factor of 2 and 8. The biggest number that will divide into both is 2. So first, transfer over your whole number. That's going to stay the same. All right, 2 divided by 2 is 1. 8 divided by 2 is 4. So 2 and 1/4 is our simplified answer. I cannot divide those numbers anymore. Much more simple than 2 and 2/8. These are the same number, but this is in simplest form. So this is the one we're going to use for our answer. How many days will the cooking oil last? The oil will last 2 and 1/4 days. So he probably should be making a plan for another trip to the store for some more oil. All right, let's do that same problem again, but using a more traditional approach. So the more traditional approach is multiply by reciprocal. I'm going to call it keep, change, flip for short, or KCF. So first, write your problem. 2 divided by 8/9. So we're not going to divide 2 by 8/9. Instead, we're going to take 2 and multiply by the reciprocal of 8/9, which is 9/8. So again, we kept the first number, we changed divide to times, and you can't just go changing things like that without changing other things to keep a balance. So we flipped the second number into its reciprocal. All right, we're now going to multiply 2 by 9/8. That's a whole number, so let's put it over 1 first. Again, there are shortcuts. I'll show you, starting example 4, how to do that. In the meantime, let's do it the long way. 2 times 9, 18. 1 times 8, 8. Now check, is this a proper fraction or improper? It's improper because the bigger number is on top. You can't leave your answer like that. So how do you fix improper fractions? You divide top by bottom. So we're going to do 18 divided by 8. 8 will not go into 1. 8 will go into 18 twice. 8 times 2 is 16. Subtract and get 2. Now, how do I get my answer out of this? Well, how many times did 8 go into 18? 2 whole times. That's our first number. How many pieces do I have left remaining? I have 2 pieces remaining out of, what was I dividing by? 8. So it always follows this clockwise pattern. So 2 and 2/8. Now I ask, is it proper? Absolutely, that's good. Next, do 2 and 8 have any common factors? Yes, that's bad. So we need to divide by the greatest common factor. 2 is the largest number. That will go into both 2 and 8. So bring over your whole number and then divide your fraction, or simplify your fraction. 2 divided by 2 is 1. 8 divided by 2 is 4. So you get 2 and 1/4, which again, we already have a sentence for. All right, let's do more examples. Our last example of dividing whole numbers by proper fractions. 5 divided by 2/3. We're going to do 2 methods on this one again. We're going to split it this way this time. So we have 5 divided by 2/3. I have a whole number, so that means that's how many bars you're going to draw. We're going to draw 5 bars. So 1, 2, 3, 4, and then 5. Now I travel over to my second number, 2/3. Look at the bottom or denominator first. It's what you're going to cut your bars into. So we're going to cut them into thirds. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Now we're prepared to look at the last number, 2. 2 is what you're going to count by. So again, first draw your bars, second slice them and cut them, and third count those groups. So we're counting groups of 2. Let's do it different this way. So there's one group of 2, there's a second group of 2, there's a third group of 2, a fourth group, fifth group, sixth group, and I have seven groups. So I have 7 whole groups. All right, you'll notice I have a piece left over. So that means we're going to have a mixed number. So we have 1 piece left over out of, what were we counting by? We were counting groups of 2. So I have 1 piece out of 2 that I wanted. So we're going to put these 3 numbers together. 2/3 fit inside of 5 bars 7 whole times with 1 piece left over, and I was looking for groups of 2, so 7 1/2. And that's going to be your answer. Okay, a different approach. Let's use our multiply by reciprocal method, or keep change flip. Okay, our problem is 5 divided by 2 over 3. We're not going to divide that. We're going to instead multiply. So take 5 and multiply by the reciprocal of 2/3. That would be 3 over 2. So we kept the first number, changed the sign, flipped the fraction into its reciprocal. I have a whole number. Let's put it over 1 to make our numbers match. And now you can multiply across the top and across the bottom. 5 times 3, 15. 1 times 2, 2. Check to see if it's proper. It's not proper. Larger numbers on top. Bad. So, long division, or top divide by bottom. You might be able to do this in your head, but we're going to show you some long division to help you get through it if you're struggling. So we're going to take 15 divided by 2, always top divided by bottom. 2 does not go into 1. 2 does go into 15, 7 times. 2 times 7, 14. Subtract and get 1. How many times did 2 go into 15? 7 whole times. I had 1 piece left over, and I was dividing by 2. So 7 1/2 is your answer. All right, next. We're going to switch to dividing proper fractions by unit fractions. So now fractions and fractions, no whole numbers. So Mary had 2/3 of a pizza. Why? Someone probably got into it and now she's not very happy. So she's going to cut that 2/3 of a pizza that she has left into some equal slices that are going to be 1/6 of the whole pizza. How many equal slices is she going to cut? I'm going to show you 2 methods. So how would this look like with bar modeling? Well, first, what's our problem? Well, she has 2/3 of a pizza. She's going to cut it into slices that are 1/6 in size of the whole pizza. Now, we don't have a whole number here. So how many bars do we draw? When you have a fraction, you're going to draw 1 bar. So if you had a fraction that was 2/3 or 1/2 or any fraction, you're going to draw 1 bar. Okay, now we need this bar to become 2/3. So how are we going to do that? We're going to follow the same pattern. The bottom, or denominator, represents what you're going to cut it into. So I'm going to cut this bar into 3 sections. Next, I look at the top number. That's what you're going to count. Now this is not going to give you your answer. 1, 2. What am I going to do? I'm going to slice it off right there. What does this represent? This represents your 2/3 of your pizza. So this part is the pizza that's not there. It doesn't exist. Someone ate it. Mary's very mad. So this is the 2/3 of the pizza that she's got left. All right, now we're going to continue to the second number. Again, bottom number represents what you're going to cut it or slice it into. So I need to recut this into 6 pieces. So 1, 2, 3, 4, 5, 6. And I'm doing dotted lines because I want to see my original cuts. All right, next, I simply need to count by groups of 1. And I'm going to stop when I get to the line. Why? Because this part's not there. It doesn't exist. So I have 1 group, 2 groups, 3 groups, 4 groups. Again, I'm counting groups of 1. So pretty straightforward. How many equal slices did Mary cut? Mary cut 4 slices. All right, let's do that a different way. So let's use multiply by reciprocal method. All right, I'm going to show you 2 different ways, one of them the long way, and I'm going to start showing you shortcuts for doing division with fractions. This does not work with all, certain ones. So we're going to write, oops, done messed up, not 3, 2/3. And we're going to divide by 1/6. Okay, first, we're going to keep our 2/3. We're going to change divide to multiply, and then we're going to take the reciprocal of 1/6, which is 6/1. Now we multiply across the top and then the bottom. 2 times 6 is 12. 3 times 1 is 3. Is it proper or improper? It's improper. You cannot have a big number on top. So what do? You divide. 12 divided by 3. 4. And again, that was our answer. So we know we're good. Now you might be saying, well, that's easy. Why do I need any shortcuts? Well, this is an easy problem. So I'm going to show you a shortcut with the easy problem, and hopefully you can apply it to more difficult problems. So let's do it again. So 2/3 divide by 1/6. Our first step still stays the same. We're not going to divide. We're going to multiply by the reciprocal instead. So 2/3 times 6/1. Okay, what is our shortcut? It goes by cross-canceling or cross-simplifying, different terms. I usually say cross-cancel. So what do? You look at the numbers that are diagonal from each other. So 3 and 6, and you look at 2 and 1. So let's look at 3 and 6. You ask yourself, do 3 and 6 have any common factors besides 1? In other words, is there a number that you can divide both of those numbers by nicely besides 1? Well, yes. I can divide 3 and 6 by 3. So I'm going to divide 6 by 3, and I get 2. I'm going to divide 3 by 3 and get 1. You have to divide by the same number. You can't just divide by whatever you want. Now, look at the 2 and 1. Do 2 and 1 have any common factors besides 1? No. 1's the only number that's going to go into both of those evenly. So I leave those alone. Notice the numbers are smaller than before, so it means it should be easier in the end to do division if I need to divide. So 2 times 2, I get 4. 1 times 1 is 1. Now, 12 divided by 3 is pretty simple, but notice 4 divided by 1. That's even easier. So the purpose of cross-canceling or cross-simplifying here is to make this easier on us. 4 divided by 1 is, again, 4. Now, if it helps you, you can jot down what you're doing. We're dividing that number by 3, and we're dividing that number by 3. That's a lot of writing, and some people don't like clutter, and it might confuse them. However, you could do that to keep track of what you're doing. All right, our next example. We've got a plank. That's basically a piece of wood. It's 4/5 of a meter in length, and a worker is going to cut it into some pieces, each 1/10 of a meter long. Into how many pieces did he cut the plank? So we're going to use both of our methods to show you the difference, to give you some options. All right, first, with bar, what is our problem? Well, we have a 4/5 of a meter plank, and we're going to cut it up into 1/10 size pieces. Remember, I don't have a whole number, so how many bars am I going to draw? I'm going to draw 1 bar. Next, I'm going to cut it into 5. So 1, 2, 3, 4. That's a little bit larger, so we're going to fix that. All right, that's better. And we're going to count over 4. So 1, 2, 3, 4. We're going to draw a line. What did we just do? This is our 4/5 of a meter long plank. That part doesn't really exist. Okay, now let's look at our next number. Denominator again means cut. Okay, so I have 5. I need to change it into 10. So I can cut each one in half to make 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Next, count groups of 1. So 1, 2, 3, 4, 5, 6, 7, 8. Do not count that. Why? Because that doesn't really exist. It's not there. All right, so how many pieces did he cut the plank? He cut 8 pieces. All right, let's do that in a more traditional way. And I'm going to show you the shortcut. So 4/5 divide by 1/10. All right, we don't divide fractions. Again, we multiply by the reciprocal instead. So this is going to become 4/5 times 10 over 1. Again, keep the first number, change the sign, flip the fraction into its reciprocal. Okay, now we're going to see if we can apply our shortcut and make this problem easier. So we look at 5 and 10. Do 5 and 10 have any common factors besides 1? Yes. 5 will go into both. So what's 5 divided by 5? 1. What's 10 divided by 5? 2. Make sure you're dividing by the same number. Now look at your other numbers, 4 and 1. Do they have any common factors besides 1? No. All right, multiply across the top. 4 times 2 is 8. 1 times 1 is 1. 8 divided by 1 is 8. Now, if I had done this the other way around, I would have had 4 times 10 and gotten 40. 5 times 1 is 5. 40 divided by 5 may be easier for you, but I bet 8 divided by 1 is going to be a lot easier. All right, next example. We're going to be dividing proper fractions by proper fractions. All right, we are going to, because these numbers are much larger, we're going to stick with the multiply by reciprocal method. So first one, 7/16 divided by 5/12. We're going to keep the 7/16. We're going to change our sign to times, and then we're going to take the reciprocal of 5/12, which is 12 over 5. Now we're going to look for shortcuts because these are large numbers. I mean, who wants to do 7 times 12? And who wants to do 16 times 5? Yeah, no one. Guess what? We're going to do it anyways. All right, so let's cross cancel. Maybe. Do 16 and 12 have any common factors? Yes. What's the biggest one? Well, 2 will go into 12 and 16, but 4 does also, and 4 is bigger, so that's going to be better. So we want to divide 12 by 4 and 16 by 4. So 12 divided by 4 is 3. 16 divided by 4 is 4. Much smaller numbers. I could have divided by 2 and then by 2 again, but this is faster. All right, 7 and 5. Do they have any common factors? No. Multiply across the top. 7 times 3, 21. 4 times 5, 20. Is it proper? No. So what do you do when it's improper? Divide. Top number divided by bottom number. So 21 divided by 20. 20 goes into 21 once. 20 times 1 is 20. Subtract, get 1. 20 went into 21 one whole time. I had one piece left over, and we were dividing by 20. So your answer is 1 and 1, 20. Now, let's do that one more time. Not using the bar modeling, but without the shortcut. I want you to appreciate shortcuts. So, we had 7/16 divided by 5/12. We're going to keep, change, and flip, multiply by reciprocal. Okay, 7 times 12, 84. 16 times 5, well, let's see. 10 times 5 is 50. 6 times 5 is 30. 50 plus 30 is 80. If you can't do that, you might have to show some extra work off to the side. So imagine, extra work. No one wants extra work, do they? No, that's weird. Unless you really love math. I love math, but I don't want extra work. Okay, big number on top. Can't have that. So top divided by bottom. And again, you only do this when the top number is bigger. If the top number is smaller, you're good to go. You don't need to do any of this junk. All right, 80 will go into 84 once. 80 times 1 is 80. Subtract and get 4. So 80 went to 84 one whole time. We had 4 pieces left over. We were dividing by 80. Well, that doesn't look the same. Why? Oh, because now I have a proper fraction. So we do not take 4 divided by 80. What do? We look for common factors. What's a number that will go into both 4 and 80? 4. So make sure you bring over your whole number. All right, 4 divided by 4 is 1. 80 divided by 4 is 20. Now it is simplified. The numbers are as small as you can get. So notice how much more work that took just because we didn't cross cancel. Okay, number 7. We're going to divide 3/4 by 3/8. So 3/4 divided by 3/8. We're going to keep the first number, change the sign to times, and flip the fraction into a/3. It's reciprocal. We're going to cross cancel, maybe. All right, do 3 and 3 have any common factors? Absolutely. Love these. 3 goes into 3. So 3 goes into 3 once. 3 goes into 3 once. So those just canceled out to both 1. Now let's look at 8 and 4. What goes into 8 and 4? Preferably the biggest number. 4 does. 4 goes into 4 once. 4 goes into 8 twice. So we made all 4 numbers shrink. This one's going to be a lot easier. All right, 1 times 2, 2. 1 times 1, 1. It's improper. You must divide. 2 divided by 1 is 2. All right, we're going to do that again. But I want to show you what it would look like without that shortcut. So we keep the first number, 3/4, change the sign to times, and flip the fraction into its reciprocal. Now you just multiply. 3 times 8, 24. 4 times 3, 12. Now this one did not turn out as complicated because 24 divided by 12 is still pretty simple. 24 divided by 12 is 2. All right, we have 2 more example problems. We're going to now divide fractions by improper fractions or mixed numbers. So our first example is 1/2 divided by 7/3. We're going to keep, change, flip. So keep your first number, change the sign to times, and flip the fraction into its reciprocal. Now we're going to see if we can cross cancel. All right, do 3 and 2 have any common factors? No, not except for 1. Do 1 and 7 have any common factors besides 1? No. So no shortcut. Too bad. All right, 1 times 3, 3. 2 times 7, 7. Now we're going to ask, is it proper or improper? Oh, it's proper. The little number is on top like it should be. Okay, next. Do 3 and 7 have any common factors? Can I make the numbers shrink? No. You know what that means? Oh, we're finished. If all problems could be like that. I know. All right, last example. Divide 3/4 by 1 1/2. So 3/4 divide by 1 1/2. We can't actually do anything with this because this is a mixed number. So what are we going to do? We must change mixed numbers to improper first. We must change the mixed numbers to improper first. Now be careful. Don't go changing your problem all at the same time because you might mix yourself up. So we're going to keep our 3/4. We're going to keep our divide sign, and we need to change this to an improper fraction before we do any multiply by reciprocal method. So how do I change this to improper? We do the denominator times the whole number, so 2 times 1, which is 2. And then we're going to add the numerator. So 2 times 1 is 2, plus 1 is 3. I keep the denominator, 2. Keep the denominator. Okay, now we have 3/4 divided by 3/2. Now you may keep, change, and flip all you want. So 3/4 stays the same. Change the sign to times, and now flip the fraction into 2/3. If you try to change things too soon, we kind of get mixed up and we forget to flip our fraction and things like that. So we want to make sure we wait to do this until we've changed that number. Okay, can I cross cancel? Do 3 and 3 have any common factors? Absolutely. 3 goes into both of those. 3 goes into 3 once. 3 goes into 3 once. Amazing. All right, 4 and 2. Common factors? Absolutely. 2 will go into both of those. So 2 goes into 2 once. 2 goes into 4 twice. All the numbers shrunk. All right, let's multiply. 1 times 1 is 1. 2 times 1 is 2. Is it proper? Yes. Can I simplify? Do 1 and 2 have any common factors besides 1? No. What does that mean? You are finished. So, 2 things to end on. All answers must be simplified. Second, never leave answers as improper. So, no improper fraction answers. And don't forget, don't always just start dividing the top by bottom. If the top number is smaller the way it should be, proper, leave it alone, like it's good. Just make sure it's simplified. All right, I hope this has helped you with showing you examples of how to divide fractions. If it hasn't, don't forget there are many other sources out there. I hope you find what you need. Y'all have a great day.